Yes, students, today we will talk about Bohr's atomic model. In Bohr's atomic model, Bohr has considered electron to be a particle as a wave. That means Bohr has advocated dual nature of matter, that is de Broglie hypothesis. So here you have a nucleus which contains Z number of protons, each of charge plus E, and outside an electron is revolving whose charge we are writing it as minus E. The force which is acting towards the center will provide the necessary centripetal force so that the electron don't fly away tangentially. So electric force is given by 1 by 4 pi epsilon naught q1 q2 by r square, the Coulomb's law. So 1 by 4 pi epsilon naught, for the sake of convenience we write it as k. First charge, that is nucleus charge Ze, and the electron charge E, by the distance between the center of the nucleus to the electron. That is equal to mass times of centripetal acceleration. Centripetal acceleration is given by v square by r. So we can say that electric force provides centripetal force, electrostatic force of attraction between the positively charged nucleus and the electron provides the necessary centripetal force. We can sum up that by writing this and this together. 1 by 4 pi epsilon naught Ze square by r square is equal to mv square by r, not r square here, it is r, centripetal force. Now according to Rutherford, electron is a particle, but Bohr said that electron has dual nature, it can even behave like a wave. So advocating the wave nature, if at all you have an orbit, say this is a crust and this is a trough, then this is a stationary orbit, so it is a one full wavelength. So 2 pi r, the circumference is equal to 1 lambda. Similarly, crust, trough, crust, trough, crust, trough, perfect wave has formed. So 2 pi r is equal to 3 lambda. Now we try here. Crust, trough, crust, but here it's not forming a perfect wave. This is called non-stationary orbit. So electron don't choose to be in a non-stationary orbit. So electron, when it is behaving like a wave, so first we are told it's a particle. Now in this process we are telling that it chooses the orbits. So this orbit will choose, this it will not. Similarly, if you see this, crust, trough, crust, trough, crust, trough, crust, trough. So 4 wavelengths is equal to 2 pi r. Whereas here it is say 1.736 lambda is equal to 2 pi r. This kind of orbit electron don't like to choose. I mean, it will not choose that orbit. So we can say that whenever it's an integer of lambda is equal to 2 pi r, that is the stationary orbit. If it is not the integer, that is not a stationary orbit. So this we can extend it and generalize it. 2 pi r is equal to n lambda, where n is an integer. So lambda is equal to h by p according to de Broglie matter wave. If electron has to be a wave, then it has to follow the de Broglie matter wave concept, h by mv. So if you put this lambda here, you get 2 pi r is equal to n into h by mv. If you cross multiply mv here and 2 pi here, you get mvr is equal to nh by 2 pi. Principally, this is the important equation. B, similarly, the A, this is the principal equation using which the total Bohr theory will be developed. Now let us see this. Taking the basic equation, k is equal to Ze square by r in the nth orbit is equal to m velocity in the nth orbit by radius in the nth orbit as a base first equation A, and mass into velocity in nth orbit and radius in nth orbit is equal to nh by 2 pi, where n is the orbit number, is equal to 2. This is the two basic equations we use it. This is derived taking electron as a particle. This is derived by taking electron as a wave, matter wave. So solving these two, this also contain V and R, this also contain V and R. Eliminating V and R, by eliminating R we get V, by eliminating V we get R. So that derivation, just you try it, you will get the answers. And the radius in the nth orbit, radius of encircling electron in the nth orbit is given by n square, h square, 4 pi square, k, z, e square, m. Removing all the constant, 4 is a constant, pi is a constant, k is 1 by 4 pi epsilon naught, z is, you keep it like that. Electron charge is 1.6 into 10 to the power of minus 19 coulombs. Mass of electron is 9.107 into 10 to the power of minus 31. If you put all these things, the two variables left over will be orbit number and atomic number. And this all remaining constants, if you solve it on a calculator, you will get the proportionality constant to be 0.53 angstroms. So the radius of the, if you put atomic number to be 1, that is for hydrogen, and if you put orbit number 1, then you will get the radius of the first orbit is 0.53 angstroms. Now anyhow, we eliminated V, found out R. Now we eliminate R from these two basic equations and we get V. That comes out to be 2 pi k z e square by nh, keeping z atomic number and orbit number, remaining all constants. If you calculate it, it comes 1 by c by 127, which is equal to velocity of light 3.3 into 10 to the power of 8, that if you can get it, 2.2 into 10 to the power of 6 meters per second. So if I put z is equal to 1 and n is equal to 1, first orbit in hydrogen will have this much of speed, the electron speed, 2.2 into 10 to the power of minus 6. So in a very small orbit of this radius, if this high speed it is revolving, so in that context, a very low mass particle can be treated as a wave. That is what is the point here. So we got V and R. Now we go to this, and in any circular motion, velocity is equal to r omega, instantaneous values. So omega we can get it from it, V by R. We got R, we got V, divide both. That means V should put in the numerator, R you put in the denominator and divide them. So you will get the omega, that is the angular velocity. The third derivation what we are doing here is. So that comes out to be 8 pi square k square z square e power 4 m by n square h square. Just divide these two, you will get the answer. So omega comes out to be dependent on z square by n cube. And in the first orbit and in hydrogen, the omega, the angular velocity comes out to be 4.159 into 10 to the power of 16 radians per second. And now we will find out the frequency, how many times the electron revolves per second around the nucleus. So omega is equal to 2 pi n or 2 pi nu. Nu is equal to omega by 2 pi. Whatever omega you got it, divide with 2 pi. So same expression will come, divided by 2 pi. One of the pi will get cancelled, and you get gamma n. Frequency in the nth orbit is z square by n cube. Here z square by n cube. Here also z square by n cube. Extra only 2 pi will come, and per second electron in first orbit of hydrogen atom revolves at 6.62 into 10 to the power of 15 hertz. That many times it revolves so fast. Coming to the time period, frequency is reciprocal of time period. Whatever you got the frequency, reciprocate it. Numerator as denominator, denominator as numerator. So n cube goes up, z square comes down. In that case, we understand that electron completes one circle in the first orbit of hydrogen atom in 1.5 into 10 to the power of minus 16 seconds. Very small time. Next is, we want to know the current associated with the moving charge, that is electron. Q by T, current is equal to charge per unit time, and time taken is 2 pi r by V n. If you write like that, you will get charge times of frequency. So the given orbit, how many times it has circulated, charge times of frequency. So charge, you write E, and frequency what you have obtained previously, that you write it here. Then you will understand that current associated with encircling charge, that is electron, is z square by n cube, same as frequency it comes, because only extra constant we have multiplied, that is charge of electron. So the current associated with that is 1.06 into 10 to the power of minus 3 amperes in the first orbit of hydrogen atom. Now comes the next point, that is when electron is moving and having a moving charge, we call it as current. Current should create a magnetic moment at the center. Magnetic moment due to circular coil is given by mu naught I by 2 R. We are not writing n, mu naught I n, because already number of times already we taken in the frequency. So once you write that, writing mu naught value as extra constant, and current what you obtained here and 2, and radius in the nth orbit already derived in the first expression, that you put it. Then you get an expression like this: 8 pi to the power of 4 k cube z cube e power 7 m square by n power 5 h power 5. So we can say that magnetic moment created at the center of the nucleus by the encircling charge, that is electron, is z cube by n to the power of 5, and that will be 12.58 Tesla for first orbit electron in hydrogen atom where atomic number is 1. And this has been derived by taking formula B is equal to mu naught I by 4 pi r, and theta should be taken in radian mode. You write 2 pi here, 2 pi cancels 4 pi 2 times. That is the expression used here. Now encircling electron is an electromagnet. So magnetic moment of that electromagnet is given by current times of the area of spanned by that electron or the current. So magnetic moment is equal to current and area. Area is given by circle pi r square. Then pi is as it is, r square previously you derived, that you substitute here in the first expression, this r value. Then many of the terms get cancelled, and finally leftover term is Mn is equal to EHn by 4 pi m, where E is the charge of electron, m is the mass of electron, n is the orbit in which it is revolving, and it is independent of atomic number. That means we can have hydrogen or helium or lithium, it don't depend on that. So this expression, by putting n is equal to 1, we get E h by 4 pi m, that's called Bohr magneton. And h by 2 pi, every time you have to write it, that is, they call it as h cut. H they write it and cross it, h cut. H by 2 pi value is h cut. And now the magnetic moment due to that circulating electron, that is a circular loop of current carrying current, is 9.26 into 10 to the power of minus 24 ampere meter square. And it has been derived using the formula magnetic moment is equal to current into area of cross section. Current and area of cross section are previously derived. Now coming to potential energy associated with a electron and the nuclear and the charge inside the nucleus is given by U is equal to 1 by 4 pi epsilon naught Z E square, that is ZE into E by distance of that. Like U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R, that kind of expression it is. So from this you will understand it depends on Z square and N square, because Rn value once you substitute, that also contains Z and N terms, that will give this. And the potential energy of the electron in the first orbit of hydrogen atomic number 1 is minus 27.2 electron volts, and it has been derived using this formula. U is equal to negative of the work done by conservative force potential energy minus FDR. You have to write the expressions and integrate, you get this expression which is done in electrostatics, that can be readily used here. Now coming to the kinetic energy of the revolving electron, you can use just half mv square. Mass, you write m, Vn, already we derived Vn in the second expression, that you can use it again here, because velocity in the nth orbit is this, that you can just square it and put it here, speed square. We will get the kinetic energy, and that comes out to be same as a potential energy Z square by N square, but the proportionality constant is plus 13.6 eV, that is in the first orbit of the hydrogen atom, energy of the electron is plus 13.6. Kinetic energy is never negative, plus 13.6 eV. By adding these two, minus 27.2 plus 13.6, we get minus 13.6 as the total energy of the electron, and it is bounded to the nucleus. Just these two expressions are to be added. Here it don't contain 2 in the denominator, it contains 2 in the denominator, that if you add it you will get same expression as that of kinetic energy with minus sign. So that's why kinetic energy will get plus 13.6 and total energy comes out to minus 13.6. We have obtained this expression by adding mechanical energy is equal to sum of potential energy and kinetic energy. This is the total energy of the electron, which is not plus 13.6 or minus 27.2, it is sum of this, that is minus 13.6 eV. Now comes many other expressions which are also useful in your future, that is ionization energy. We define ionization energy as energy required to remove an electron. So we have to take it from nth orbit and send it to infinity. So minus 13.6, when you supply plus 13.6, it will jump from first orbit to the infinity outside the atom. So that expression we can write wherever may be the electron in the nth orbit up to infinity. When you write it comes out to be 13.6 z square by n square eV. Ionization potential, ionization energy we get in electron volts converted into joules divided by electronic charge. So by during conversion you get 1.6 into 10 to the power minus 19, that and this get cancelled. So directly you can write whatever answer comes here, same thing you write it, just write volts. Ionization energy comes in electron volts, ionization potential comes in volts. Excitation energy, you are shifting the electron from lower state to higher state, lower energy state to higher energy state. You have to give the energy. So difference in the energy between these two orbits is called excitation energy, that comes in electron volts. And if you multiply divide with electronic charge, you will get the same answer in volts. The expression for that is 13.6 z square 1 by n square minus 1 by n plus 1, wherever you are excited the next level, in volts. Next, binding energy. The total energy whatever we got it is negative. That means electron is been in the capture of or under the attraction of nucleus. Minus indicates the attractive force. So that much energy if you give it back, it gets free from the nucleus. That means minus 13.6 with which the electron is being held by the nucleus, if you supply it back, it will go out. So that energy required to separate the electron from the atom is called binding energy. Next, these all values, particularly the total energy whatever we got it, z square by n square with a constant minus 13.6 for first hydrogen atom, always z is 1, orbit number 1 n is, so you can write it as minus 13.6 by 1 square, minus 13.6 by 2 square, second orbit minus 13.6 by 3 square, third orbit, like that. If you write all the values, say up to 7 I have written. First one comes out to be minus 13.6 by 1 square, minus 13.6, minus 13.6 by 2 square, that is minus 3.4, minus 13.6 by 3 square, that is 9, minus 13.6 by 9 gives minus 1.51, 4, 5, like that. You go on, substitute the values, you get energy of each of the orbit of hydrogen atom in first, second, third, fourth orbit is minus 0.85 electron volts, fifth orbit minus 0.54 electron volts, sixth orbit minus 0.38 electron volts, seventh orbit minus 0.28 electron volts. If you give this much, electron in the seventh orbit goes out. If you give this much of energy, electron in the sixth orbit go out. Now difference between these two comes out to be 0.16. If you give 0.16, it will jump from 5 to 6. Now see, for example, electron jumps from fourth orbit to third orbit. Then you have to, that while you jump, it will release this much of energy. If you supply, it will jump from 3 to 4. If it comes from 4 to 3, it will release. Required, released. Like that. So difference of the energies also you have to calculate. So jump from first orbit to second orbit consumes most of the energy. Second to third less. Again from directly first to infinity, it is minus 13.6. Out of minus 13.6, a lot of energy is to be consumed in going from first orbit to second orbit. By hearting these values will reduce the time of calculation involved in your calculations in competitive exams. Before Bohr, some scientists like Lyman, Balmer, Paschen, Brackett, Fund observed the excitation energies or de-excitation energies of electrons in different orbits, and that spectrum results are available. De Broglie concept and Bohr concept were theoretically available. Practically, we have to get the values matching this Lyman series, Balmer series and all. So, the expression we take it from Bohr's model, 1 by lambda is equal to R into 1 by n final square minus n initial square. By substituting E is equal to h nu and hc by lambda, you get 1 by lambda as Rydberg constant times of this. And Rydberg constant value is 1.097 into 10 power 7 or 1.1 into 10 power 7 per meter, this Rydberg constant. And always in all the series, one formula is enough. 1 by lambda, this is called wave number, or reciprocal of wavelength is equal to Rydberg constant times 1 by n final square minus 1 by n initial square. And in every series, n final remains same. In Lyman series, always the electron comes to first orbit. In BOHRS series, always electron comes to second orbit. In Paschen series, always electron comes to third orbit. In bracket series, always electron comes to fourth orbit from higher orbits. So more than 1, you can have all other numbers except 1. So 1 you already fixed for first lowermost orbit in the Lyman series. It can come from second to first, third to first, fourth to first, fifth to first, like that. So during a transit, minimum wavelength means maximum energy, maximum wavelength means minimum energy. So minimum wavelength comes when excitation happens from infinity to the first orbit. Maximum energy comes when it jumps from just above orbit 2 to 1. So minimum wavelength is 1 by r. They have to by heart this value. 1 by r is equal to 1 by Rydberg constant. Reciprocal of Rydberg constant is 911 angstrom. You can approximately remember is at 910. And maximum wavelength comes out to be 4 by 3 r. 1 by r you can write as 911 into 4 by 3, you will get 1214. So excitation is from 2 to 1 and 3 to 1 and different values. So what is the maximum wavelength, minimum wavelength? Write this value, divide. 1 by r gets cancelled, 4 by 3. In this way, BOHRS series, the jump is from third to second, fourth to second, fifth to second, sixth to second, infinity to the second. Infinity to second gives you minimum wavelength, third to second gives you maximum wavelength. In that way, you can calculate for Paschen series, bracket series, fund series. Now you are not interested in doing full calculation, you have separate formulas. So the wavelength given by whichever orbit it starts from and whichever orbit it goes to, n1 square into n2 square by n12 square minus n1 square into Rydberg constant. This value by using, you can directly get the lambda. To get lambda maximum, n square into n plus 1 whole square by 2n, don't square it here, 2n plus 1 into r. Lambda minimum is n square by r. Lambda maximum by lambda minimum is n plus 1 whole square by 2n plus 1. So by actually better method is always go with the basic formula and get all of them. You need to remember less, but if you want to do the calculation more quickly, you can remember wavelength in any transition, maximum wavelength, minimum wavelength, ratio of wavelengths can be calculated with these formulas. If you have patience to by heart and your memory is good, please do that. Now whenever electron go from one level to other level, say nth level to ground level, then we can use this formula, n into n minus 1 by 2, say 4 into 4 minus 2. So from fourth orbit it jumped to first orbit, then 4 into 4 minus 1, that is 3. 2 ones are 2 twos are 3 twos are 6. So they will get 6 transitions possible, that is fourth to third, fourth to second, fourth to first, third to second, third to first, second to first. These many transitions are possible, these many energies are possible for electron if it jumps from fourth to first. So between fourth orbit and first orbit, 6 transitions are possible. 6 independent transitions are possible. Similarly, if first orbit is not involved, say second to third, fifth to sixth, sixth to fourth, like that, then you can use this formula to get the number of spectral lines. How many number of spectral lines means how many independent spectral lines will come can be calculated with this formula. And if ground state is involved, this formula. Either you just substitute the number 1 in this, automatically this will convert into this. So now these all things are to be used to do calculations involving BOHRS model. Thank you. Repeatedly see the video. This is a crispy atomic physics. Thank you. Panchavati Ravi Sharma.